Thank you. To start with, you guys all know the spiel by now. Huge shout out and thank you to all the sponsors that make this event possible. Another shout out that's not on the slide, but to all the volunteers and organizers that make it possible. It wouldn't be like we couldn't run it without them. So another round of quick applause to those people. If you haven't by now, I'm probably not going to convince you to do it, but there's probably still time to join the bingo and put your name into the pot for some of the prizes. And yeah, so this is the last round of talks before the final keynote. I'm talking about testing, so I half expected an empty room, so this is great. A disclaimer up front, I am not going to tell you what to do about testing, and if you don't do that, you're stupid, and like there's one thing to do. I don't think it works like that for a lot of things, but especially for testing. There's no silver bullet. There's just so much nuance to it, so much that depends on how you work, how your team works, how your projects work. So instead, what I'm gonna do is inspired by those, am I too loud? Ongoing discussions about like what's the best testing shape and all of that. Inspired by that, I want to look underneath that and see like what is the core motivation behind all those things? Why do we test? What are we trying to achieve? And hopefully find some useful insights, but also just trigger some interesting thoughts for all of you guys to then hopefully take away and make more informed decisions yourself. What you want to do about your testing situation. And to get started, I want to start with the basics. So I want to go through like the common test types and then move into those shapes. Most of you will be familiar with that. Again, it's the basics, but I think it's important less from an educational standpoint, but from a establishing a common language kind of thing. When we talk about different test types, we usually put them into layers, and like the lowest layer usually is unit tests. So you look at the lowest level of your code, the smallest units of your code, and you want to test those. And the benefit of that is your smallest units of code ideally are by definition small, so they're usually functions. You pass something in, you get something out. So writing those tests is fast, running those tests is usually very fast. Then we get to the next layer where we put multiple units together and run them as an integrated system, could call it service. This might also be running multiple services together and testing like the integration between the services. This is where all the memes on the internet live. This is because while your units might work as you expect, once you put them together, once you test them as an integrated part, the integrated system might not behave as you expect. This is also where it already might be slightly controversial of me saying it's integration tests at that layer. You might call it something different. You might even split it up into multiple layers. Some people like to have component tests and API tests, or call it service tests. That's all great. Like, call it whatever makes most sense to you. Just be aware that if you call it something else, or if you have a different definition, that will make an impact on when we start talking about test distribution and where you want to put most of your tests, because obviously that will change with the definition. Next one is end-to-end tests. If you're like me and you're building web applications, this usually means running all the systems together, but also running your web app in a headless browser. And the idea is to try to get as close as possible to the end user as you can. So you're pretending to be the end user. You're literally defining the pathways you think the end user will take. I don't think there's a clear distinction between those three layers. That's also often a misunderstanding, misconception. I think it's a gradient. Like it's a tests just get more and more integrated as you add stuff to them. It's not a clear split between this is a unit test and this is 100% an integration test. So I think that's worth keeping in mind when talking about those kinds of things. Two more layers that I think are important, that are sometimes mentioned but not always. Again, as a JavaScript developer, I think this is super important, static tests. If you work in another language, this might come out of the box and not even be optional, but if you work with JavaScript, using TypeScript as like a static layer of testing, even underneath your unit tests, of like as the lowest layer of your test coverage, TypeScript is a testing tool, at least in my opinion. And the other end of the spectrum is manual testing. So it's often left out because in your perfect world, in your ideal scenario, you don't want to manually test. But there might be scenarios where it's just not practical to automatically test. Like it's much more practical to do testing manually for some features. But much more important than that, when looking at your testing, you often start with a status quo, and that status quo usually contains a lot of manual testing. And that's the whole point of, like, you look at your test suite because you want to see how you get the manual testing away from it and start more automated testing. Be aware of that manual testing. Have that as part of your, if you visualize what your test suite looks like, manual tests should be part of that. Ironically, that won't be in any of my next slides because we're mostly looking at like ideal cases. So let's look at those ominous shapes. This was basically the inspiration for my talk. Starting with the most popular one, probably everyone knows that, the pyramid. The idea being, again, you have those 3 layers, and the distribution is basically depicted by that pyramid shape. So we have the gradient from at the bottom, it's more isolated, like we said, smallest unit of your code, to more integrated end-to-end, which tests much more of the behavior and much closer to the end user. You could also, and more importantly, describe it as the lower parts run a lot faster. They are usually written a lot faster, so they're considered cheaper, whereas the further up you get the pyramid, it's supposed to be more expensive. That's not always true, and that's kind of point of the talk, is there's nuance to that. The reverse of the pyramid is often called the ice cone, sometimes called the pizza shape. I don't know about you, but when I started developing, that used to be the anti-pattern. Like, we used to use that picture to say, like, this is not what you want, and be careful that your test suite doesn't go in there. I feel more and more it actually becomes a thing that has a following of, like, people actually advocate for it, with the main argument being end-to-end tests are really valuable because they are so close to your user. You don't test implementation detail, you test what your users can actually do with your system, and that's what you care about in the end, which is absolutely valid and is a good argument. It just ignores all the other arguments that we have for shapes like the pyramid or some of the other shapes that we see in a second. The next one I only included because I thought it was great. Like, I wasn't aware of all these shapes that were flying around, and then I stumbled across the crab, which essentially, in a nutshell, it's just the ice cone in a nicer shape, like a bit funny and nice to talk about. But it has the same idea. Like, the heavy focus is on end-to-end tests. It's usually the 3 triangles at the bottom. It's like 2 of those are integration tests. It's just split up into service and API. And then the third one is unit tests. So the distribution, again, comes like heavy end-to-end, a little bit of integration, almost no unit testing. So similar to that, like, it has arguments, but I think it ignores a lot of the arguments for the inverted shape. Then we kind of start evolving the pyramid a little bit. So the next one is a diamond, and again, it started off as kind of like describing like an anti-pattern, but it more and more moved into something, okay, let's use that and try to make a sensible shape out of that. So the idea is you have the pyramid, you kind of agree that that's a good shape to aim for, but you also acknowledge that naturally the pyramid usually starts to erode. And when it's eroding, it usually erodes from the bottom. And the reason for that is because the unit tests are so close to your implementation detail, a lot of them get too brittle because of that. Like, you're testing your implementation detail every time you change that code, even if you don't change behavior, those tests suddenly start failing. And it's just something that you see in especially large test suites. What erodes first are those too far on the implementation detail unit tests. So the idea with the diamond is basically the shape that comes naturally out of that. And then, actually don't remember the exact year, but like Spotify then made the honeycomb a really popular shape and idea flying around in the testing communities. And it's literally just a further evolution from that. So the idea is end-to-end tests and unit tests are important, but the heavy focus is on integration tests to find that right balance. And what I like about that is that Spotify did a really good write-up of all that. So they actually went through the effort and described why they were doing it, which is what I tried to describe. So they were able to refactor the internals without touching any tests. So they can change implementation details. As long as the behavior doesn't change, they shouldn't need to touch any of their tests. In their example, they could change from Postgres to NoSQL. The tests would still run normally. But they also, and this is the primary reason why I like the write-up, is they go into the trade-offs. So they acknowledge that this benefit comes at multiple trade-offs. So the first trade-off is a loss of speed of text execution. So what I said before, unit tests run fast. The further up integrated you go, the slower your tests run, which means like the feedback loop will get worse and worse. The second trade-off that they acknowledge is that we might lose some feedback accuracy. And what that means, and the people here who write end-to-end tests will know that when an end-to-end test fails, as long as it's reliable, that's good. But often you don't know exactly why it failed. You know the screen where it failed, or like the action that you're emulated, but you don't know exactly which line of your code is causing that failure. So those are the two trade-offs that they acknowledge, and they say like it's worth when you look at the balance. Where we come out of that is the trophy, which is like has become a really popular shape, especially in the front end community ecosystem. It basically just takes that honeycomb and slaps the static layer underneath it, and again acknowledges static testing, especially in the JavaScript ecosystem, is super important and should still be part of your prioritization. This is also where, for me, it started popping up more and more, those discussions around testing, and Twitter does what Twitter does. It's like it's getting quite hectic and toxic, and like, the permit is dead. Whoever uses the permit is like, it's too old now, and whatever. Like I said in the very beginning, I don't think that's a good way to look at it, because there's so much nuance to it. There is no one way that works for everyone. So instead, I think we really want to have a look at why we do testing. Like, what is the core motivation behind all of that? Or why do we not test? Like, why do some teams do not take the extra step to actually look into testing or maintain their testing? And the usual excuses for not writing tests are we don't have time for that. And I think at least in this room we can all agree that's a backwards argument. Like, that's your usual agile argument of like, we have to deliver quickly. Anything that doesn't deliver, it just doesn't take into consideration you're going to spend much more time debugging and fixing your bugs than you would have had writing your tests and preventing them in the first place. The other reason is tests just keep failing, and they're unreliable and they're brittle, and especially the more tests we have, the more brittle they become, so it's not worth it. And I can relate to that in the sense that I've worked at teams where that was the case, and it is painful and it is annoying. But again, I would say the argument is backwards. Is you're looking at you're not doing tests right, or your tests aren't great, and then draw the conclusion, testing is bad. It must be testing as a whole. So instead, it's worth just looking at why are your tests brittle. Again, looking at why the diamond has that erosion of like, some tests are just too close to implementation detail to be useful. So why do we write tests then? Even there's some bad reasons for that. What I often see, and I worked at agencies or like companies who outsource testing, is testing just becomes a measurement of like to make your manager happy or to make your team lead happy. And there's a famous like economical law, the Goodhart's law, which describes it well. It's like any observed statistical regularity will tend to collapse once pressure is placed upon it for control purposes. In simpler words, what that means, any measurement that starts becoming a metric fails or discontinues to be a useful measurement. Because basically people start gaming the system or start to learn gaming the system. If you have test coverage as like your KPI and your personal performance gets measured by how much you increase the test coverage, you will find ways to increase test coverage without necessarily helping the underlying goal. So that means that it doesn't mean don't measure, It just means measure for the sake of information, measure in the sense of you want to find out which parts of your code base need more testing. Don't measure to add them to the KPIs. So if that's not a good reason, what are good reasons? I want to bring up two. There's plenty of them, but the two main ones for me are stability for the end user. That's the obvious one. And it's fine if that has like underlying, you do it because you want to make money, because you want your business to make money. If those are the motivations, that's good, because you're still acknowledging to be able to make more money, you want your users, or you need your users to have a stable experience. 70%, 77%, and this is like a study from the University of Toronto in 2014. They did it on large distributed systems, but I think that the general rule applies generally. So it's they found that 77% of bugs, of production failures, could be reproduced by unit tests, which means we're all human. We all make mistakes. Every one of us writes code that likely 77% of bugs that it causes could have been prevented by writing unit tests with them. Which, once I learned about that, it just changed the way I looked at unit tests as a first layer of defense. The other one is enabling refactor, and that for me that's the big one. It's the famous quote from Tim Bray. I think it came from him. It's the first one I saw mentioning it. Code is way more often, it's read and updated way more often than it is written. And it's so true. Like, you write code once, and then for the rest of that code's lifetime, that code will be updated by you, that code will be updated, more importantly, by other people. So keep that in mind when you write code, but more importantly, keep that in mind when you write tests. You want to write tests that actually describe what that code is supposed to be doing, aka behavior, rather than writing tests that just describe your implementation of that, because other people can see that implementation in your code. And I think it's important because there's a reason why code is so often updated. Like, stuff changes, products need to evolve, software is called software for a reason. We want products to change over time. And another great quote, walking on water and developing software from specification are easy if both are frozen. You will never have a specification that doesn't change over the lifetime of your product. So just be aware of that. Your primary goal here is to allow developers to be comfortable changing existing code. And to increase that developer confidence, tests are a super powerful tool. To dive a little bit deeper into that, I want to touch on a topic that might cringe some people here. I apologize up front. I want to touch on TDD. It's not a deep dive because I don't have time for that. It deserves a talk on its own. But I want to talk about two specific things that TDD advocates that ties exactly into what we just looked at. The first one is the concept of red-green refactor. Most of you might have heard of it, might have done it. The core idea is whenever you write code, you have three primary steps. One is you start with writing tests that describe the behavior of what you're about to write in code. So you write tests before you write any code. And again, keyword here, I hope you see the common thread, you describe the behavior of what you want it to be. Then you write your code, but you write the minimal amount of code that you can to make the test pass. You get a free pass and you have to use it. To ignore all the rules, all the established practices in your team, just make that test pass. And then, and this is critical because that's the step that most people skip, and then they start complaining about test-driven development doesn't work. You refactor the code. So, and I'm as guilty as anyone of that. Often you get to that second step, you make that test pass, but then your product manager or whoever is already in your neck with the next feature, and it's like, okay, I do it later, I clean up later. And it's like that later never comes. So like the refactor step in red-green refactor is critical. You basically then take that time to clean up your code, break it out into multiple files, clean up service APIs, whatever it means. And why that works is because as part of that cycle, you're already verifying that your unit tests are behavior driven, not implementation detail driven, because you're changing the implementation already as part of it. So you already find the tests that are too brittle and can remove them or change them or whatever. The next one is self-testing code. And I think it's a really bad name because it doesn't really describe what it means, but like it's a really good concept to be aware of and to kind of keep in mind when writing code and writing tests. It's something that Martin Fowler, one of the big advocates for test-driven development or testing in general, coined. And what it basically means is tests should be part of your delivery, whatever that means in your team. If you're agile, if you have sprints, tests need to be part in the sprint planning discussions. If you do code reviews, tests need to be code reviewed. If you have a definition of done, which you hopefully have, tests are part of that definition of done. The second part of it is you should run your tests constantly, as often as possible. That means locally, while you're developing, you should constantly be rerunning, or even as a watch mode, have your tests running. But even beyond that, have your tests automatically run when you push to a feature branch. Have your tests automatically run when you merge that feature branch. It's just really important to have those steps in place to make tests actually part of your culture in your team. And then once it's part of the culture in your team, you can, as a team, it's much, much easier to work together to get to that stage. And both of those things try to achieve those two key improvements that I said you want to see in your team, right? You want to increase the developer confidence by shortening the feedback loop. That's running your tests often. That's writing tests that give you immediate feedback. And yeah, you just generally need to get it as part of your day-to-day workflows. So I'm super passionate about TDD, but that doesn't mean that I'm saying like everyone has to do test-driven development. I just think it's got a bad reputation, and I think it has a bad reputation for bad reasons. I think there's a lot of misconceptions flying around. I think there's a lot of just misunderstandings or myths, and they lead to people hating TDD and not even trying. So I wanted to mention at least two of them just because I thought it was interesting. TDD means I have to write my test first, and I did that in my run-through of Red Green Refactor. It means that you should write your test before doing anything else. Technically, that's true. But if you don't want to do that, don't do it. Like if you take anything away from this talk, just don't follow anything by the book. You don't have to. It goes for testing, it goes for other things. Agile as like the biggest one on the top of my mind. But take away why people suggest you do it. But if it doesn't work for you, if your creative flow usually goes like, oh, I want to pseudocode first, I want to draw diagrams or even start coding really, then do that. Do that, write your test afterwards. As long as you make sure that feedback loop still comes to conclusion, and that you don't spend too much time writing the code. Again, remember the second step of Red Green Refactor, minimal amount of code. That prevents you from getting rabbit hole, that prevents you from getting too attached to your solution while you haven't even really figured out if it achieves the behavior that you're after. Keep it short, keep it quick, get to that second stage where you then, even if you start with a code, get to that second stage where you have a test that proves that the behavior works, and then still do the refactor. Just be aware when you change the parameters that you're deliberately doing that. And it's interesting because Kent Beck, who is the guy who basically invented test-driven development, Martin Fowler, who I already mentioned, who's a huge advocate, they did a 45 YouTube video podcast series with DHH, who you might know did an article and or talk on why TDD is dead. So it was a really interesting discussion because he was arguing for all the reasons why TDD is just not working in bigger teams. And you have like the inventor of TDD and one of the big advocates listening to that and having like a really constructive conversation. And what turns out is even Kent Beck says like, okay, your argument is like you don't like writing tests first, then don't do it. It's like it's not hard written rules. We're not having a Bible here. He wrote a book where he suggested writing tests first for a reason. He explained the reason. If you do it differently, as long as you understood the reason and you deal with the trade-offs, that's totally fine. For those interested, like Kent Beck, basically his reasoning was his personal comfort/anxiety. Like he gets anxious when he doesn't have that test first and can verify quickly that his implementation matches the behavior, but that's just his personal development style, and he acknowledged that. So if you haven't seen those videos, definitely worth watching. I have a link to the slides at the very end, and there's a bunch of links in the slides themselves. The second one is TDD says I have to mock everything that's within my unit test. I have to mock everything that's not part of the unit test. Basically, a lot of people against TDD are just against mocking, and they say mocking is a liability, and it's just then you have to maintain the mocks as you change the code and all that kind of stuff. The irony here is TDD doesn't have a strong preference on mocking at all. It's again mostly those people who try to evangelize it, who try to say like, oh no, you have to follow TDD by all of these steps. They say mocking is a must. Kent Beck himself is totally against mocking. Like he tries to avoid it wherever he can. Martin Fowler actually took it a step further, and I think he puts it best. So he has the concept of isolated and sociable unit tests. So it's really, when we talk about this layers, unit tests, integration tests, end-to-end tests, unit and integration is really more a how much goes in there, like how big is the part of the system that you're trying to test, not how many dependencies does it have. And what he's saying is, this is basically in the context of the discussion around when the honeycomb started becoming really popular and people said like, oh, the honeycomb is so much better than the pyramid because it focuses way more on integration tests. That's way more sensible, much better balance of your tests. And what he says, like, their notion of integration tests just sounds very much like what he would call sociable unit tests. And that makes the whole discussion moot, because like what I tried to explain in the beginning, your definition of those test layers very much affects what those distribution and ideal test shape looks like in the end, right? So he's actually acknowledging all of that. He says like the honeycomb is a great shape if that's how you define integration tests. If you haven't, definitely read those books. Again, Kent Beck, Test-Driven Development, Martin Fowler on refactoring. They're great books. They're not mind-blowing. Like there's not anything like outlandish of concepts in there. It's just a really good write-up of those fundamental concepts and a really good structure and with good examples. So for me, it really made a change when I started getting into testing a lot more. All right. Wrapping up, kind of just trying to summarize what I went through and what I tried to explain with the talk so far. A few points that I would give as like advice to focus on when you either try to improve your test suite or try to start the test suite in a legacy project. First one that I actually haven't mentioned so far, be the advocate. Yes. Be the advocate. That actually goes for anything in life, not just testing. So 2 things to take away from this talk. 1, don't follow anything by the book. Second one, be your own advocate. If you're passionate about something, if you think something is worth it and useful, don't wait for somebody else to give you permission to do it. Your company will never prioritize tests. Your PM will never prioritize tests. It's not in their direct interest unless they're also really passionate about it. It's on you to say like, cool, I learned about these things. I read up on these. I think it's useful. Go around and start educating people. Go around, show them why it's useful. Go around, show them how you would approach it. Show them that it's an approachable thing and will lead to all those outcomes that the company also wants. Second point, embrace tests as a way to improve developer confidence. So I hope I explained that quite well. That's the key point. Like you want your developers to go into a code base that they might have never touched before, make a change and not spend like 3 months just manually testing to make sure nothing is broken. I've worked at several companies where we started off without a test suite and then gradually started developing one and now have established test suites. The difference in delivery is massive. So this, again, it just blows out that argument of like, we don't have time for that. Teams will develop 10 times, 20 times quicker when they have confidence that they can push out to production because they have tests that will catch at least major things. It all comes back to that, like, never deploying on a Friday. It just shouldn't be a thing. Like, yeah, maybe you have a buffer in there, like, not as you leave the office. But like, if your team has a no Friday deployment policy, then there's probably something wrong in your test suite that makes people uncomfortable, and that makes it likely that something breaks, and you should look into that. Third one, test behavior, not implementation details. So this is where all of the shape discussions shouldn't be around shape. It's around how you find the balance to get as close to the user as possible while not losing, like we've seen in the honeycomb write-up example, while not losing the benefits of a quick feedback loop by tests running quickly and the accuracy of tests. So this is why the honeycomb is so popular, is because the integration layer tries to find that balance. If you can go closer to your unit tests without going into the implementation details, that's fine, then go more with unit tests. It's really just about the concept that tests describe what your code is supposed to do rather than how it's working under the hood. Automate your tests. Run them often, run them constantly locally, but automate them not only in CI/CD. If you don't have a CI/CD pipeline, definitely look into setting one up. But even beyond that, have like a Git pre-push hook that runs your unit tests in TypeScript before you push into your feature branches. It's not that it's not supposed to be a gatekeeping thing. It's not supposed to be like, but I want to check you before you push into a branch. It's the idea of that constantly running. You want to be constantly seeing your tests pass, which will help you not spend like 3 months on a feature to then run CI/CD and then see that 15 tests fail, and you then have to go back and dig out, why are they failing? If you constantly run them, you have that short feedback loop and accuracy of this is what's actually causing the failure. I haven't talked about that at all yet, and I wish I again, a talk on its own almost. Identify the most common and likely points of failure in your system. So I slightly touched on that with like code coverage. Again, not a great KPI, but definitely a measurement you should do. Do code coverage to see what parts of your code base deserve more tests. Like, where do you have the biggest hole in your test suite, and patch that hole. There's other really good measurements that you can do that, again, just help you identify what needs more testing. Bug tracking is the obvious one. Like, if you have a bug tracking tool like Bugsnag or Sentry, use that to identify which parts of your code base fail most often, and even see like which parts of the code base are used most often by users. Like, what are the most critical parts of the product. Another one is cyclomatic complexity, which is just a fancy word for code complexity. There's very established, very good rules around like how you can calculate code complexity. There's tools for pretty much every language out there that use static analysis to give you an actual number for that, for your code base. Basically what it does is it looks at your code and sees like logical branches and lines of code in your files and all of that. And it really helps to identify what parts of your code base need more testing than others, but also which parts of your code base you should probably start refactoring, make it simpler to avoid those clumps of high complexity in just some areas. Don't just blindly follow a shape or strategy. Don't just blindly do anything, really. Say you start with like, okay, you and your team agree the pyramid is a great shape. Don't just stop there. Have that discussion around like, okay, for your code base, it's JavaScript, so you do add that static layer. For your code base, you also say like, with JavaScript, we're also using like a third-party design system, so that's all in NPM. That's actually not with us. So a lot of your units actually don't live in your code base. That changes like how much unit tests you should be writing, right? Your ecosystem might have other things. There are in general other natural erosions or natural things that depend on your circumstances. So for me, it's often I want to add security tests to my suite. Security tests are best towards like more towards the end-to-end and the static layer. Like if it's discoverable by static analysis, I have it in the static layer, otherwise it gets closer to the user. Same with accessibility. Like there's accessibility testing tools where you probably want more of your end-to-end testing so you can actually test the accessibility in different browsers, different devices, and all that stuff. Visual regression testing, you can't get around of like actually rendering it on at least virtual devices. So all of that kind of stuff, depending on what your needs are, what your requirements are, will shift what your end shape will look like, and that's fine. Don't just follow the pyramid just because the pyramid is of any other shape, just for the sake of it. And in a similar fashion, the last point is have smaller milestones. If you're trying, especially if you go into a legacy code base and you're trying to introduce testing, don't just show that final shape and like your end goal and tell the whole team like Kilimanjaro, here we go, without any hiking experience. So bring people on a journey with you. This has a great pyramid in the background. You will see it as it grows. Like acknowledge that you have a lot of, say you start with a lot of manual testing, acknowledge that. Show how much of your time you're actually spending with that manual testing, which will make it much easier to actually justify spending that time in other places writing those tests. Then start building up your stuff. We're not in like a physical world here. You don't have to build up the pyramid from the bottom up. Start wherever the fuck you want. Sorry for the language. Personally, for me, what I've always found best, and again, I'm building web applications, so it might be different for you. What worked best for me is starting at the static layer and the end-to-end layer. The end-to-end layer just gives you really quick, really broad coverage of your application, which immediately increases developer confidence. The static layer is usually just the easiest to add. TypeScript, even if you don't add strict typing straight away and just have it run against JavaScript files, already catches so many bugs that people were like, okay, didn't know that all of that was essentially broken. So just start with those and have that as a clear milestone, and then start building up your inner core, start having integration tests, having unit tests, work with your team to actually figure out how you define those, what your frameworks are, etc. And then you will just naturally eventually get to that stage where you're like, okay, this is actually a good test suite, a good distribution of tests for our team, for our product specifically. All right, that's all I think I had time for. QR code goes to the slides if anyone wants to look at the slides. And I'll leave that up for another 10 seconds or so before I thank the sponsors again. Very awkwardly. No. Yeah, but that, honestly, again, huge shout out to the sponsors. It's truly like they make this possible. Yeah, that's it. Thanks.
Thank you, Julian. That was a great talk. Now we are opening the floor for questions. If anyone has any question, please raise your hand.
All right, I'm going to try and mind palace some things together from that talk. You talked about the study that said things were preventable by unit tests. You talked about red-green refactor and saying, write just enough code to pass a test that you've put in there. You talked about cyclomatic complexity, which I love. Thank you. That study, were they preventable by a unit test or a unit test with specific inputs? Do you remember?
There's obviously like...
There's a reason I'm asking.
It's not all 77% were
no, yeah.
one time. From memory, the majority was just preventable by unit tests because a lot of the failures are actually failures by not handling errors. So that's like I should have actually mentioned that. It's a good question because the other fault that we probably all have when we start with testing is we test the happy paths.
Yes.
We test the good cases.
That's where I'm going.
Yeah. especially in unit tests, but like even in your intent tests, you should always test like the unexpected, like the what if the user does that? What if the input is actually something that's completely broken? Make sure that your system fails in a predictable way.
Yeah. So the question is, how do you go from I've just written my I've passed my test to then expanding that to have enough, branch coverage, condition coverage, whatever, to be valuable in the long term?
Another good question. I think it's worth acknowledging that red-green refactor is not you do those 3 steps once for your whole feature work. You should constantly loop over those for, basically, I don't want to sound like a project manager here, but try to split your work up into small chunks of work. And each small chunk of work should be that red-green refactor. So for me, what you described is my first small chunk of work is implementing the feature that it works. So I do the red-green refactor. Then the next chunk of work is dealing with failures. And then I start again with the red. I start the tests for the failures first, and then go. And I should say that I'm praising, like I'm teaching more here than I'm actually practicing, if that makes sense. It sounds easy when you say it like that. It is hard in practice, and again, that's also worth acknowledging. Like it's not as easy, but if you try to follow it like that, of like be mindful about every piece of work that you do should have at least those steps in your mind, I think you naturally get to that growing test suite that works. The other benefit of that is the other direction. If you keep doing that, of like running your tests with everything that you do, you will identify those brittle tests very early on, and you can actually get rid of them. That's the other thing that people don't do that they should do more often. Delete tests if they're not useful. Your test suite doesn't have to grow to the millions as long as they're actually catching it.
Thank you. Any more questions?
You said that as soon as you put a KPI on something, then people will game it. How do we instill a positive test writing culture amongst people?
By showing the benefit of the tests outside of just the number of tests or the number of coverage. Personally, for me, like the biggest win that you get is when people, like in your development team itself, is when people start feeling that confidence, start feeling like, oh, I made this change and tests are actually failing, and now I can fix it. And before I push it to production, like those aha moments are usually the ones where the team starts to get behind you if they're not already. And then the step from there is just making that visible to the rest of the stakeholders as well. Like make sure that the PMs understand, that your business lead understand what's happening and why the developers are getting more comfortable with stuff. Make it like, I'm probably, I shouldn't bash onto it, but like the no Friday deployments for me was my plan for getting the team behind me was to show that testing can help us deploy on Fridays, as stupid as it sounds. Of like, let's get rid of that rule. Let's make sure that our deployments are stable, like we don't get so many issues reported by customers essentially, and then work our way from there. But it is a journey, like it is work, and that's why I'm saying like you have to be the advocate. You have to ideally rally people that you know are also passionate, rally them around you, because you will need to put work in to actually convince others.
Thank you. Any more questions?
Hi, thanks. What are your thoughts around using AI for TDD?
Yes, 100. Like personally, best use of AI. I am still skeptical that AI will write better production code than most developers. Testing is the perfect use for, like, writing tests is just, usually it's just a tedious task. So as long as you still define what you want to have test covered, and then AI just generates a scaffolding for you, perfect, 100%. Like my use of Copilot is 95% scaffolding tests, and then going from there. It's also the better and better the LLMs get, the more those AI tools will help you identify what you should be testing. Which comes back to we have the tendency to just test happy paths. Ideally, the AI tells you oh, but you forgot about all these 3 ways it can fail. So, I think this is going to be the biggest application for AI tools for the next foreseeable future. I'm going to be proven wrong in 6 months.